Hello friends, this is Durga again from Technology Mentor / ITversity, and currently I'm working on a playlist to explain you how we typically do MapReduce development in Hadoop using Java-based MapReduce APIs provided as part of the Hadoop distribution itself. So far we have seen several things. We have seen HDFS briefly, and then we looked into MapReduce APIs, and we have seen the default behavior of behavior of the default mapper and reducer, including the input formats and output formats. And then we have developed a simple MapReduce application for row count, in which we have used the existing reducer, long sum reducer. And then we have seen the MapReduce lifecycle, and also we will be I will be adding two more videos between key value types and the HDFS copying data, and then I have actually added few videos related to HDFS and MapReduce execution framework, which will talk a lot more detail about HDFS, how the MapReduce programs will be executed, and what are the frameworks around it. As part of this video, I will consolidate all the parameter files that are important for HDFS and MapReduce, especially using the latest framework, which is called as Yarn. Then I will start talking about important parameters like block size and split size, how they are related, etc. So that being said, I'm logging into my Hortonworks cluster or VM. It's a single node cluster, so I'm already in that. And as I have mentioned in the other videos about HDFS as well as Yarn or MapReduce, the configuration files will be under directory etc, under which there will be a directory for Hadoop, and not only for Hadoop, for each and every technology in the ecosystem like Hive, Pig, Scoop, etc. there will be a directory here. But forget about all those things now. Hadoop related parameter files will be under /etc/Hadoop, and there is another subdirectory called conf, and you can do ls-ltr, and here you will find a bunch of XML files, out of which we are interested in site.xml files. And forget about KMS. I am also not sure what it is, but if you look at the other four files, we have a core site.xml file, which is the core to the MapReduce. It will have parameters impacting HDFS as well as MapReduce execution framework. And then HDFS site.xml explicitly for distributed file system of Hadoop. And then there are two parameter files, MapItSet and yarn-site.xml, which are for execution framework using Yarn. If you are using Classic, which I have covered in the other videos quite in detail, you will find only one XML file, MapItSet.xml file. Being a developer, you while programming your MapReduce applications, you will not typically deal with these XML files directly. You will override elsewhere, that I have already covered as part of the video running jobs and changing parameters at runtime. I have shown several options. I will not be covering how to do that further, but I will definitely execute some programs changing parameters and at runtime wherever it is relevant. And also we will try to change certain parameters or add new parameters as part of our programs also. Okay, and that being said, let's quickly review what these XML files have. It is both kind of a recap for the users which have gone through my other videos about HDFS and execution framework. If you are new, you will understand a few important details about the parameter files. So the most important and the only mandatory parameter in a cluster if you are not running locally on your PC, if you are using a cluster, the only important the only mandatory parameter is this fs.defaultfs, and it will give you the name node IP address and the port number here using SDFS protocol. So this will tell you where your name node is and all the nodes in the cluster. So typically Hadoop cluster will have hundreds of nodes. Majority of them are considered slaves with uh, data node, and if you are using yarn, node manager running on each of the slave nodes, and all of them including masters, which are name node, secondary name node, etc., resource manager or job tracker if you are using classic, etc., have to know where our name node is. And for that reason we have to hard code our name node IP address using this parameter called fs. So parameter files will control how your cluster runs, and also how to bring up the cluster. Also, while bringing up the cluster has to be configured in a particular way. For that we will use parameter files. It is not new at all. You use the concept of parameters and parameter files while deploying any technology, not just Hadoop based technologies. And then it have other parameters also, but we will not see at this time. And then if you go to hdfsi.xml, at the beginning when I actually covered uh, about HDFS briefly, I have mentioned that uh, the file will be divided into multiple blocks, and the size of the block is determined by this parameter called dfs.block size. In this case it's 32 MB, but by default it's 128 MB. Sorry, not this one. I don't know from where this came. This is not correct. This is the one, dfs block size. So dfs block size is the default one, and it is 128 MB. You can see it here. Don't get confused with this. I'm not sure from where it came. This is the correct parameter. And also for fault tolerance, there is another very important parameter which every developer and administrator should know. It is default.replication. I am currently showing from a single node Hortonworks virtual machine, and as we have only one node, the replication factor is defined as 1. Even if you have more than one, as we have only one node for everything, still there will be only one copy of each of the blocks, and this replication factor will help in terms of fault tolerance. So these two are the very important parameters which you need to understand, memorize. It will come as a question in the certification for sure, and also in most of the interviews they will ask about this thing. And then we have two files for map reduce execution framework, which is yarnset.xml and MapItSet.xml. And if you look at yarnset.xml, the most important parameter is the resource manager parameter. Resource manager, yeah, this yarn.resource manager address will tell you where your resource manager is, and typically this will be running on a separate node like the name node, and we have to pass this IP address to all the slaves on which the counterparts of resource manager, which are called as node managers, are running. For that reason we need to hard code the IP address of resource manager. In this case my name node and resource manager are running on the same node, so the IP address is the same, but the port numbers are different. But in true production cluster, or even any cluster in the enterprise, your resource manager should run on a different node than name node. And then so yarn is the execution. Yarn takes care of the resource management while executing the MapReduce programs. But while executing the MapReduce programs, how it will be executed is determined by MapItSet.xml file. And here there are a few important parameters which you need to be familiar with. One is IO sort MB, which is here hard coded to 64 MB. So let me explain where this comes into picture. If we go back to our map reduce life cycle, so I have mentioned that the output from the mapper will be written to a output buffer. So this output buffer is a memory component, and IO sort MB controls the size of this output buffer. And for my single node virtual machine cluster, it is 64 MB. But typically the mapper tasks or reducer tasks will be running with 2 GB memory for JVM. In that scenario, we will typically give at least 1 GB to IO sort MB. So that being said, another important parameter is split size. I think it is not here, so it will be so the value will be default when the program is ran. So yesterday we ran the program. Even though the parameters are not defined in these XML files, if you go to there is something called job.xml. If you go to the job.xml for that particular job, you will get the details about the about all the about all the parameters that are in effect at the runtime of the job. So for example, let me go to this IP. My IP is http 192.168.225.129. That is the IP address of my Hadoop single node cluster. And as the parameter yarn resource manager address says, the port number is 8050. The IP address was alias over there, which I don't have on my PC. That's why I'm using the physical IP here rather than the alias, which states which says sandbox, etc. So once you have the IP address and port number, if you want to use the same IP, same alias which is defined in yarn.resourcemanager.address, you can actually update your etc host file by providing alias matching to that name on your PC or any other laptop. Anyway, in this case, I'm just giving the physical IP address and the port number which is defined as per the yarnset.xml file, and hit enter. Okay, let me see. Okay, this is resource manager address. There is another important parameter called HTTP address, and that one will actually this one, web app.address. Resource manager web app address will give the web interface for the resource manager, and the port number is 8088, not 8050. So sorry for that. Hit enter, and you can see the job that have run in the as part of the last video. And if you want to look at the details of it, you can click on this history under tracking UI. It's a link, and it will take you to the page where your job details are stored after job is run. Even while running the job, you will see a application master or something here, and even then you can actually click and go to the details. Okay, it ran into the server not found because it is using alias here. So what we can do is I can actually update my host file. So I am opening my host file. If you are using Windows, you should be familiar where your host file will be. And here we can give the IP address and alias. Okay, this is my physical IP address and this is the alias. And come out of it. And now if I run this, it will work. Okay, so this is the called as job history server. Once the job is completed, it will go to the history server. No need to worry about it if you don't understand. But when you click on that history, it will take you to page something like this, and you can click on about jobs, tools, and then you can actually click on configuration. And here it will give you all the details about the configuration, and you can actually search for SplitSize. And this will actually control how the data should be processed by MapReduce. By default, the block size and split size are same. So if you run a MapReduce job, the mappers will be determined by the number of blocks for the file. And if you go back to our previous program, you can see that the file large deck is splitted into 3 blocks. So here you can see that by running hdfs fsck command or Hadoop fsck command, we see that the file large deck, which is of 350 MB size, is divided into 3 blocks, as we have 3 blocks. And as the split size, the mean split size is 0, here split mean size is 0, and the number of mappers generated or created to process this 350 MB file, which is split into 3 blocks, is 3, because number of splits is 3. Now if you increase the split size to 256 MB, the number of splits will be 2 and the number of mappers also will be 2. If you increase it to 512 MB, the number of splits will be 1 and number of mappers also will be only 1. I have explained all these things in a lot more detail as part of the other videos about HDFS as well as MapReduce Execution Framework. And now let us try to run our card count program on New York Stock Exchange data. Okay, and let us review the data first. Okay, we are in the right directory, and we are in the code directory. Let us go to the data directory, and there is NYSE and there is a raw data directory. And here if you see, there are 5 directories, and each are suffixed with year for which the New York Stock Exchange data related to. And then if you go to one of the year and do ls minus ltr, you find that there are many small files which are of size 100 KB. And ideally we should not directly process data like this, but I would like to run our card count program on this path on the VM and see what will happen. I have already copied data to my cluster, as I have done in my last video, where I have shown running our New York Stock Exchange application to get the card count, to get the record count. So I'm again logging into the same cluster, which is single node cluster, and data is already copied here. Let us copy this data to, let me see, I would have already copied to the HDFS also. Right now this raw data is on OS level directory, and even it is there on HDFS also. So let us let us get the record count for the year 2009. Okay, for that let us run the same program which we have ran. In this case I have to just change the input path, which is raw data, and I will give the directory path here, not the file path. So you can actually pass either the directory or the file, but when you pass the directory you have to make sure that all files are similarly structured for most of the MapReduce applications, otherwise you will get inconsistent results or incorrect results. So output record count NYSE 2009. So Hadoop jar, the jar file name and the class name in which we have which have the logic to get the record count using MapReduce APIs, and then it takes two parameters, input path and output path, and hit enter. If you actually go back to here there are around 260 files for year 2009 and 261 files, and if you see, even though the overall size is only 20 MB because each file is 100 KB, and using 260 files it will be around 20 to 23 MB. Even though the overall size of the data is just 22 MB, which is lesser than our block size, but the number of splits is 261 because we have 261 small files. So the block size is applicable only if the file size is greater than the block size. If the file size is less than the block size, then each block for that file will be of the size whatever the file is. So in this case, for all those files we will have only one block in HDFS, and the size will be approximately 100 KB for each of the blocks. Okay, it is very important to understand this thing. It will help you to determine how many mappers will be invoked while running a program, and there is a reason why I'm showing it here. Soon we will try to address this issue to reduce the number of mappers to execute this program. If you see, it is taking a while, almost 1.5 minutes, still only 16% is done. I'm killing this job, and I will try to place something, some trick here to reduce the number of mappers to execute this program. So for that, what I am doing is I am writing all the small files into a larger file. So in this case, it is raw data NYSE 2009, have a bunch of CSV files, and I am writing it into NYSE 2009.csv. Now you can see that this file is just 26 MB, and now let us copy this to HDFS. So it is copied, and now let us run the program. Here, instead of giving the path in raw data NYSE underscore 2009, I will give the file name directly, which is 2009.csv, which we just copied to this location. And then output file, we have to give a unique name because it will create a new directory, and you can see that it creates only one split for the entire data set and only one mapper to process the data, and the performance will be much better. So it is extremely important to understand the side effect of having too many small files, and that we will see how we can address that. Here we are trying to see the impact of SplitSize by playing with it in common to determine how the mappers will be created while executing the program. So now if you see, there is only one split. I think it is in waiting. This job seems to be not completed. Let me see that. If you want to list the MapReduce programs that are running at a given point in time, you have to run MapReduce job list command. Yeah, so the previous job is not completed yet, it is still running. Let us kill that. You can do that using, make sure when you are on project, you don't kill blindly like this. You need to understand the effects of it, and typically it would be requested to admin to kill a job. Typically developers might not have permissions to kill the jobs like this, especially in production clusters. In development, yes, you will be having this. So now the previous one is killed. Probably this job might have already completed. You can use this URL and go to the browser and hit enter, paste it and hit enter, and the job is already complete. Once that previous job is killed, this got completed within no time, within just 13 seconds. So let me run it again so that you understand it clearly what is going on. So even though we have 261 files, we have data for 261 files in one bigger file which is consolidated. And now instead of using 261 files like earlier, it is using only one split, and it created only one map task, and it executed the program within no time. So that is the difference between having your file sizes at right size. That being said, we have seen the parameter files, and we have seen the split size. We have seen the details about split size as well. So I hope you understand both about the parameter files, coresite.xml, hdfsi.xml, and mapitSet.xml, as well as the ansite.xml, and also the concept of split size, because we will be using it in future. Especially for this program where too many small files, we will see how we can address the issue, and without consolidating also how we can reduce the number of mappers while while developing our MapReduce application. So I'm not only explaining the concepts but also trying to create the problem statement so that all these things can be thought of when we actually develop the MapReduce application, the next MapReduce application. That being said, I hope you are enjoying the content so far on my channel. If you have not subscribed yet, please do so. I will upload a lot more content than Hadoop or big data. And if you like a particular video, please click on the like button. And if you want to provide feedback or ask any technical question respect to a particular video, please use the comment section of that video. Thank you. Bye.